So we're going to start with number 1, which is the arc sine of 4 pi over 3. And in order to start this problem, we start with inside the parentheses. So we have the sine of 4 pi over 3. So I'm going to treat that as a separate problem. And we are going to do the sine of 4 pi over 3. Recall that yesterday's notes, we are taking the sine of an angle. Therefore, the output is going to be a side length. Reviewing of unit 1, we know 4 pi over 3 will have to lie in the third quadrant because this is 3 pi over 3. This must be 4 pi over 3. Creating our triangle, we know the reference angle will be 60 degrees. We know the y coordinate is going to be negative square root of 3 over 2. We know the x coordinate to be a negative 1/2. Now looking at our picture, we are finding the sine of this angle. So we're looking for our y value, or the opposite over a hypotenuse of 1, which our answer for here would be negative root 3 over 2. Now let's take our result and bring it back into the problem. We now are replacing inside the parentheses with our negative root 3 over 2. So now we are taking the arc sine, or we said if you wanted to write it as sine inverse of negative root 3 over 2, it means the same thing. So we have sine of, here is a side length. If this is a side length, we know our resulting answer should be an angle. Now looking at negative root 3 over 2, the inverse of sine has a restriction to our first and second quadrant from negative pi over 2 all the way to pi over 2. So I'm crossing out quadrants 2 and 3. Negative root 3 over 2 means that my y value has to be a negative root 3 over 2, leaving us in the fourth quadrant. My reference angle now must be a 60 degrees. The angle at which this has to be would be a negative pi over 6. Therefore, summing up, that the arc sine of 4 pi over 3 is negative pi over 6. Now looking at number 2, we're talking about a tan inverse of negative 1. Tan inverse of negative 1. Looking at the tan inverse of negative 1, recall that we are now using the inverse, so our input is a side length. And in this case, since it's a tangent, that means it's a ratio of 2 side lengths, the y divided by the x. Therefore, our output is going to be an angle. So in order to know what angle will give us a negative 1, sometimes it takes some guessing and checking, or if you know what will give you negative 1, it's a lot faster. Some natural guesses that students make is y divided by x, so they go to 0 divided by 1. But if you do 0 divided by 1, it's undefined. So therefore, 0 and 1 will not give us a ratio of negative 1. The second natural guess students make is 1 divided by 0. Again, that is a result of 0, not negative 1. So the combination of 0 and 1 is not the point we are looking for. The correct result would have been our square root of 2 over 2 divided by the square root of 2 over 2. Now that gives us 1. We are looking for negative 1. which means one of these has to be negative in order to have a negative 1 in a result. The point square root 2 over 2, comma square root 2 over 2 then is the point we are looking for on our unit circle. Going back to the tan inverse has a restriction from negative square root 2 over 2 to square root 2 over 2, where they are not included. Root 2 over 2, we know it has to be one of them negative. We are crossing off quadrants 2 and 3. For number 2, we are looking at the tan inverse of negative 1. Recall that when we take the tan inverse, we are given the input as a side length. And in this case, since we are talking about tangent, it's the ratio of two side lengths, the y divided by the x. Therefore, the output is going to be an angle. So we're looking for a ratio of the y divided by the x to be a negative 1. Some common mistakes by students would be that the y divided by the x must be a combination of 0 and 1. However, if you use the guess and check method of 0 divided by 1 is undefined. Therefore, this is not the correct ratio. The other most common mistake is 1 divided by 0, which is 0. Again, not the correct ratio we are looking for. The correct ratio we are looking for in order to get a 1 would be that the numerator and the denominator are the same. And the only coordinate to have the numerator and denominator the same is the square root of 2 over 2 and square root of 2 over 2. So, in order to get a negative 1, we know one of these has to be negative. Let's just keep that in mind as we move forward. So in looking at that tan inverse, we know the restrictions of tan inverse are in the first and fourth quadrant, where it's from negative pi over 2 all the way to pi over 2. Now, since one of them has to be negative, we automatically know it's the fourth quadrant. So root 2 over 2, negative root 2 over 2. We know this then has to be a 45-degree reference angle. And to get a 45-degree reference angle, we're looking at a result of negative pi over 4. So in result, the tan inverse of negative 1 is negative pi over 4. In number 3, we're taking the sine of an arc cosine of negative a half. Same as number 1, we start on the inside with the parentheses, and we treat it as a side problem. So we're looking at what is the arc cosine of a negative a half. Again, arc cosine is that cosine inverse, so we know the input is a side length, and we're looking for an output that is an angle. Our cosine inverse is a restriction from 0 through pi. So I'm crossing off the third and fourth quadrants. So to have a cosine of negative a half, that means our x value is negative a half. And if our x value is negative a half, we know our y value is root 3 over 2, giving us a 60-degree reference angle. A 60-degree reference angle we know has a denominator of 3, but to get in the second quadrant it must be 2 pi over 3. So let's take that angle and now let's insert it back to the original problem. We're looking for what is the sine of 2 pi over 3. If we're taking the sine of an angle, we know the output must be a side length. You can use the same picture or you can rethink of it again as 2 pi over 3, we know this is 3 pi over 3. 2 pi over 3 is in that second quadrant with a reference angle of 60. Sine means it's our y value, and we know it's root 3 over 2. So, root 3 over 2. To recap, we have our sine of arc cosine of a negative 1/2 is equal to square root 3 over 2. Number 4 can be a little bit tricky because we're looking at the cosine of arc tangent of 4 over 5. Again, same as the previous. We're going to look at inside the parentheses first and look at that as a separate problem. So we're looking at the arc tan of 4 over 5. So we're given the side length of 4 over 5, but that doesn't appear on our unit circle. So reviewing back to Unit 1, we were given situations where it was not on the unit circle. And we need to refresh our memories that tangent is the opposite over adjacent. So when we go to draw our picture, and the arc tangent is a restriction on the first and fourth, so I'm crossing out the second and third. If we have an opposite that's positive and the adjacent is positive, it must be in the first quadrant. So the opposite is 4. The adjacent side is 5. And in order to go and find our hypotenuse, we need to use the Pythagorean theorem. 4 squared plus 5 squared is equal to c squared. So you get 16 plus 25 equals c squared. So therefore c is equal to the square root of 41. Now, we don't know what this angle is, but what we could do is use the picture for our insert. So now we're finding the cosine of this picture that we created. So the cosine is talking about, again, the cosine is the adjacent over hypotenuse. So finding the adjacent